Today we're going to be talking about finding the surface area, lateral area, and volume of more 3D figures. We're going to be focusing on pyramids, cones, and spheres for today. So we have a little bit of each type. This first one here is a pyramid that we're going to be working with. So they gave us the base edge. They probably should have told us that this is going to be a square pyramid that we're using right here, where we would know that all four sides of it would be 24 for the length of the base edge. The pyramid's height is 9 meters. The height will go from the center of the base to the vertex. We like to call that, or at least I call that, the true height. We also have what's called a slant height, which is the height of the triangular face of the pyramid, and that's always going to be going down the center of the triangle that makes this pyramid, and it is found in our formulas. It's like a italic L, and it's called the slant height, which is different from the true height. So for lateral surface area of a pyramid, the formula for that is 1/2 the perimeter of the base times the slant height. So we're going to need the perimeter of the base and the slant height for that part. For the surface area, we're going to add this part in plus the area of the base. Now, of course, we could do each triangle and then, find the area of a triangle, and then there's 4 of them, and times that by 4, and then add the base. That's another way of doing the surface area. I'm going to focus on the formulas from the formula chart, though, for this notes. The volume of all pyramids is 1/3 of the area of the base times the height of the pyramid. So we'll be using that formula here. So to do these, we need perimeter of the base, we need the area of the base, and we will need the slant height. We're able to find the perimeter of the base and the area of the base by just using the fact that it's a square base, and if each side is 24, then we have 4 times 24 is 96 meters for the perimeter of the base. And then to get the area of the base, it's going to be 24 times 24, and so that's just 576 meters squared. Whoops. For the area of the base. Now we need to find L. To find L, we're going to be doing Pythagorean theorem using this triangle that's formed when the height goes to the center of the base. So this is the center of the base, so this part of it is half of the way across the edge. So it's going to be 12. So we have a right triangle with sides of 9 and 12, and we'll do Pythagorean theorem to find the hypotenuse. When you do Pythagorean theorem, you find that the slant height is going to be 15. It also comes from a Pythagorean triple. This is the 3, 4, 5 triple. It's just been multiplied by 3. So you might notice that. So now we have everything we need to plug in for our formulas down here. So we're just going to start plugging it in. So 1/2 the perimeter of the base, which is 96, times the slant height, which is 15. When you simplify that down, you get 720 meters squared for the lateral area. For the surface area, the 1/2 PL, we already have that part. We know that that part is 720. And we're just going to add the area of the base. We found the area of the base to be 576 already, so then it's just a matter of combining like terms. 1,296 meters squared for the surface area. Now for the volumes. The volume is 1/3 of the area of the base, 576, times the height, which be sure you use the correct height here. That's probably the most common mistake, is people using the slant height when they should use the true height, using the true height when they should be using the slant height. This is a regular H, so it is the true height of 9. The formula chart will have an L if they want you to do the slant height. So 1/3 576 times 9 is 1,728 meters cubed for the volume of that pyramid. We have another pyramid here that we're going to look at. This one has a base that is shaped like a regular triangle or an equilateral triangle. It has an edge of 10 across there for the edge, and it has a slant height of 4. Now, for this one, they did not ask us to find the volume. So let's think about the formulas that we need so that we can only have to find what we need to complete the problem. 1/2 PL is the lateral area. 1/2 PL plus B for the surface area. So we are going to need the area of the base. What we do not need is we don't need the height of the pyramid. So we will not have to worry about trying to find the height of the pyramid. So I'm going to draw the base of this for us, maybe. Try to, there we go. Good. So we've got an equilateral triangle base with sides of 10. And we could do, we have a lot of formulas for the area. I'm going to use the 1/2 apothem times perimeter, because I think people are struggling with that one and struggling with the 30, 60, 90 still, so I'm going to go over that. Heron's formula would be my favorite method for doing the area of this triangle. If you prefer that method, or if you know how to do that method, you could use it. So I know that I have to take the full side and then half that to get onto this triangle here, and it is a 30, 60, 90, which the rule is x root 3, 2x, and we have the 60 being a 5. So that's a little bit difficult. So we know that when we go from the 60 to the 30, we're going to divide by root 3, and then you would rationalize that by multiplying by root 3 over root 3. And we find that every time what ends up happening is that you end up dividing by a root 3, or dividing by a 3, sorry. It's kind of late. It's almost 11. Dividing by a 3 and putting a root 3 on top. So this is what the 30 would be. And then the 90 would be just to triple that 5. So you get 10 root 3 over 3. So we're going to put that onto the triangle. So we've got 5 root 3 over 3, and then 10 root 3 over 3. And so now for the area of this regular polygon, we're going to do 1/2 apothem times perimeter. So 1/2 the apothem, which is this 5 root 3 over 3, and the perimeter, which would be 30. And I'm going to write P equals 30, because we're going to use that in another place too. So we just need to simplify this. So the numerators would be 5 times 30, 150 root 3. The denominators 2 times 3 is 6. And then when you simplify that, you're going to get 25 root 3 for the area of the base. So now we've got the perimeter, we've got the area of the base, we can go ahead and complete the formulas. So right here, 1/2 the perimeter times the slant height. They gave us the slant height was 4. So we're doing 1/2 times 30 times 4. So that's going to be 60 meters squared. Don't forget your units. And then over here we have 1/2 PL, which we just figured out. So no having to figure that out again, because we just found it. Plus B, which is 25 root 3, and then you just think if you could combine them, and you cannot combine them here, so you just write them, and that's the exact form of your answer, and that's meters squared still, and so we have our answers in exact form. We're also going to look at cones today, so we're looking here at this cone, and this is a net of a cone. I wanted to have this problem here just so that you could see what a net of a cone might look like. It's kind of interesting. This would be like the circumference of this circle here, and it could all fold up and make a 3D cone. And I'm going to draw what the 3D cone would look like for this. Of course, I'm not drawing to scale because this is larger than what they had. And then the height going to the center of the cone, and then the radius going over. So they have the radius here at 3 centimeters, and this 5, where it's at, it's kind of interesting, and I wanted to point this out for you for when if you ever have a net of a cone. This would be the length along the edge, along the side here of the cone, and so that's the slant height. And we don't really have the true height, but you can see we have chosen our favorite Pythagorean triple here. It's a 3, 4, 5 triple. So you can use Pythagorean theorem to come up with the height, or you might notice it's a triple. So when we're dealing with cones, we need the radius, which we know is 3. We need the height, depending on the formula, which is 4. And we've also got the slant height, which is 5. So your formulas are going to use these 3 values. You really won't need any other information to do the formulas. For this, we're finding the volume and the surface area of the cone. Now I'm wondering if I only did surface area. No, I only did volume. I worked these problems ahead of time. Oh well. Okay, so let's do the volume and the surface area. So when you're doing the surface area of a cone, let's kind of talk about how this relates to the pyramid. The pyramid formula is 1/2 PL plus B. It's the same formula for a cone, but if you look at your formula chart, it looks a little bit different. So we're going to fill in some information here and talk about how it simplifies. The perimeter of the base is 2 pi r, and the area of the base is pi r squared. They only have one base here, right? Like how our prisms from Friday, they had 2 bases. So this only has 1 base because it only has 1 base in the figure. So this right here, this 1/2 PL, filling in P here, the 1/2 and the 2 simplify out, and it's really just pi RL plus pi r squared. Now if they wanted the lateral surface area, it's just the first part of this, the pi RL, because pi r squared is the area of the bottom circle. So we know our surface area formula, our lateral surface area formula, and our volume is 1/3 the area of the base times the height, just like a pyramid, but it's a cone, so we're going to go ahead and fill in 1/3. Of course, I'm writing it wrong. 1/3 pi r squared h. So filling in the base as pi r squared. So now I'm going to find the surface area and the volume. So the surface area here is pi RL, and we know R is 3, and we know that L is 5, plus pi r squared, and R is 3 again. There we go. And so we're just going to simplify this. So 3 times 5 is 15, and that had pi on it. 3 squared is 9, so that's 9 pi. So our surface area is, if we combine these together, and they both have pi, so we can put them together, is going to be 24 pi centimeters squared, because it's surface area. And that's area, so it has a squared unit on it. And now we're going to do the volume. So for the volume of it, we're going to do 1/3 pi r squared, and r is 3, times the height. So the true height there being 4. So this is what we are plugging in. So 3 squared is 9 times 4 divided by 3 is going to be 12 pi centimeters cubed for the volume of this cone. Next, we have a couple more cones, pretty much doing the same thing. We need to know the radius. We've got the radius here at 12. We've got the slant height at 13. We could do Pythagorean theorem to find the true height, h. It is a triple. It is very much not drawn to scale. The height would be 5. Notice how it's doesn't quite match with the way the drawing is drawn, but that's how it works out. If you do Pythagorean theorem here, you do get 5 for the height. So our lateral is going to be that pi RL. So that's just pi times the radius, which is 12, times the slant height, which is 13. And so that is 156 pi, and that had a unit, meters squared. So that is the answer for the lateral area. The next one is the surface area, which takes that pi RL. So we're going to use that 156 pi, and we're going to add pi r squared, adding in that base. So we're taking this from above, and we're adding pi r squared. So it's 156 pi plus pi r squared, pi times 12 squared. So that's 144 pi for that part, and 156 pi for that part. And then you can combine them. They both have pi, so you can add them together. And you do get 300 pi meters squared. Again, that's area, so it's meters squared. Then we have our volume, and our volume is 1/3 pi r squared h, and so it's 1/3 pi times 12 squared times the true height. And again, be real careful. The true height here is 5. Do not put 13. That's the common error. So 12 squared is 144 times 5, and divided by 3 should be 240 pi meters cubed for the volume of that cone. So let's do the next one, doing the same thing. Again, Pythagorean theorem to find the missing piece of the triangle. You would get 6 meters for the missing piece. The radius of this one is 8. The height, well, I'll do them in the same order I did the last one. Radius slant height is 10, and height is 6. And so pi RL here for the lateral, so that's pi times 8 times 10. So that's just 80 pi meters squared there for the lateral surface area. This one, pi RL plus pi r squared. So that's going to be that 80 pi from above plus 8 squared is 64, so 64 pi. And so 80 plus 64 is 144 pi meters squared for the surface area. And then for volume, 1/3 pi r squared h. So we just did pi r squared, it was 64 pi, so 1/3 64 pi times the height of 6. So 6 times 64 divided by 3 is going to be 128 pi meters cubed for the volume. Again, check your units. That's going to be something that people are going to be struggling with this unit, as well as be sure you're using the height that goes with that formula, and you have to memorize your formulas. So the next shape is spheres, and this is the last shape of the day. So the spheres formulas. There is no lateral area for a sphere. The surface area is 4 pi r squared, and the volume is 4/3 pi r cubed. And so these are the formulas that we're going to be using. On number 1, we want both of these, and they gave us the radius, and that's the only missing variable from the whole formula. So they don't have to give you a whole lot of information here. So this is going to be 4 pi times 7 squared. So that's 7 squared is going to be 49 times the 4 is 196 pi, and that was centimeters, so centimeters squared. And then the volume is going to be 4/3 pi times 7 cubed. So cubing this 7 is 343. 343 times 4 divided by 3, and it doesn't work out cleanly. So we're just going to end up doing, I'm going to write it down, 343 here. We're going to do 343 times 4, and that's going to be the numerator, which is 1,372. I'm going to put pi in the numerator, or you could put it beside it, either way. And then 3 is still on the bottom. It doesn't divide nicely, so we're going to leave it in fraction form, and that's centimeters cubed. So doing the same formulas over here, and they gave us a radius of 3. So you could pause the video and try this one out, and then quickly again to check your work, that would be the best thing to do. Surface area, 4 pi r squared. So that's going to be 9 times 4. It's going to be 36 pi millimeters squared. For the volume, 4/3 pi 3 cubed. This one's kind of interesting because the 3 on the bottom is going to cancel one of these 3's, and it's going to end up being the same as the surface area. That only works out when you are using 3 for the radius. This is 27 times 4 divided by 3, 36 pi millimeters cubed. Last two have us solving, doing some backwards work as we're solving. They gave us the surface area right here, so 110.25 pi is the surface area, which is 4 pi r squared. So we're going to solve for the radius, and then of course they want the diameter. So we need to make sure that we double the radius before we write our answer. So one thing that I love about this is that they both have pi, so you can divide by pi by canceling that out. I'm going to divide by 4 before I start square rooting. You want to isolate your r squared before you square root. So 110.25 divided by 4, and I did this in my calculator, it gave me this, and I did not round that in any way. And then we're going to square root it. So I square rooted this whole answer in my calculator, and it gave me 5.25 for the radius. And they had given me 2 decimal places, so having 2 decimal places is acceptable right now. And then they wanted the diameter. So we've got to multiply it by 2 to get the diameter. So that gives us 10.5, so 10.5. And the unit was feet squared, but that was area, so this is going to be feet for the diameter. For the last one, they gave us the volume of 36 pi, and I have a typo here, and I did make that typo personally, so oops, feet cubed is what that was supposed to be for volume. So the volume, which is 36 pi, equals 4/3 pi r cubed. We want the surface area, but we need to find the radius in order to get the surface area, so we're going to solve this equation. What's great, again, they can divide by pi by canceling the pi's out. That's perfect. Then, to manage the fraction here, we're going to multiply by the reciprocal of 3/4. So to get rid of the fraction, again, multiply by the reciprocal of it, 3/4. So that you no longer have that in your work. So here that canceled out, it gives you r cubed, and then 3 times 36 divided by 4 gives me 27 on that side. So then here, to continue solving, we're going to have to cube root because it's r cubed, so cube root is the opposite operation for that, giving you the radius of 3. But that's not the answer to the question. The question wanted you to find the surface area, which is 4 pi r squared. So you're going to do 4 pi times 3 squared. So it's going to be 9 times 4, 36 pi. So the answer is 36 pi, and it is feet squared for that one. Most of the time when we're working these, it's uncommon to have such a perfect number in your cube rooting and your solving and everything. So, go fraction form if you are not getting nice answers, or if it's telling you where to round, keep the full decimal as you go with your work and don't round until the very end.